Thank you. My name is Per Levin I'm a consultant. I've been also associated to the KTH as an associate professor. This work was in line with the Swedish Program, which is a trade standard for energy use in buildings. And it was developed in order to meet the requirements on specific energy performance 10 years ago, roughly. So we are developing rules for how to calculate and how to measure and validate energy use in buildings, in new buildings especially. And it's all free of use at the home page. So in this context, we did an energy performance calculation competition, which we also did 5 years ago. And this is to obtain results from calculation programs and different users and see the spread on the predictions of the energy use with the same conditions. And we also want to promote the use of the SWEB standards and verification methods that we have developed. So the case here is a preschool built in 2014 up in the north of Sweden, where we have measured energy use for heating and domestic hot water, building electricity and tenant electricity. All the contestants were giving access to drawings and relevant information. And we had 27 registered competitors, and 19 of them completed their task. We did in 3 stages. First, you did it only by drawings, and when the building was done, the design was finished, and then the occupancy came in the first year, and we verified that with the verification stages. So it's 3 steps really. And in this presentation, I'll give you the results concerning thermal bridges only. There were a lot of other results and also a lot of input and outputs from the programs, of course. But the people contributing to this are consultants working in the business of energy calculations and design of buildings. So as the results here, the share of thermal bridges of the total conduction heat loss, you can see the contestants from A to S, here 19 of them, and the percentage value for the thermal bridges of the building total building conduction heat losses. As you can see, it ranges from 3 with the person L and G to 30%. So it's a factor of 10. It's very different than, although many have a common level of between 10 and 20 units. And this is their calculations. So why is it? So if you look at the heat loss factor from the thermal bridges, the other was a part of the total. So this is narrowed down to just the thermal bridges. We can still see that the contestant G has very high, but not the highest heat loss from the thermal bridges, and we see the L is also. And the information we got from the contestants was that now contestant G had an assumed value of a percentage-based value on the thermal heat loss. So you first calculate the U times A heat loss, the sum, and then you add for the thermal bridges a percentage value, and in this case then 30%. And some of them will calculate from detail by detail, also some assumptions, or some computer programs give you the details by detail. As a default, you can choose between poor, good, and excellent on a scale. And some, 3 of them have also calculated based on the drawing details that were given for the building envelope. They have calculated the based the individual thermal bridges and added them together. So it's still a big difference here then. And if you look at the total building energy performance calculated by all these people, you can see the red parts in this are the heating to the ventilation system or heating to the radiators. And you can see that L, which has a very low thermal bridge, has very high heat, has higher heating than G, that had a very high thermal bridge, and so there's very little connection between thermal bridge losses and the heating energy losses, which is not a very well. It's for the total. It's many factors that influence the total energy loss, energy performance of building, of course, in the calculations. We try to narrow it down so you can use, we told them to use the same climatic data, which about 75% did, and the others didn't. And there's many other factors that influence this, of course. And thermal bridge is a small part of it, but. So why are there difference? Well, the difference in you use experience values as additional percentage number to the heat loss factor, the sum UA, or just the addition to U values. It's very different, and you cannot really keep track on all the additions normally. You have what Björn told us, the one-dimensional U value that is used instead of the 2 or 3-dimensional calculations. There are different built-in defaults in the energy calculation software, which give you the difference, and every calculator gets it's an expert on his program, or he uses the same value normally as previous time or something. And then we have the area loss, area differences, where you have the overall internal measures or the wallpaper concept, where you don't calculate the middle floor structures, which are left out basically. And that is what it's called in the Swedish building code. It says the wallpaper method. So actually the thickness of the floor, intermediate floor structures are not included at all in the area, overall internal area. So what happens then if we see this is just an example of, you take a drawing detail, you transform it into the program for thermal bridges, and then you go either you calculate your psi value, and then you, in this case, where you have the overall internal measures, the left lower case, you have the perimeter value of the psi, and you add the U value here times the height, so we can compare the two. The reference case in the other end is that you have no addition, no subtractions, because you don't have this thermal bridge. It's not included at all. In the first case, you have the U value over overall internal as a base, then you have to subtract it normally. And this is the U value is not installed in the middle floor structures. So in this difference, it would cause the deviation of a few percent, or even though this is a very small thermal bridge, low values. And you can see the spread on the competitor's calculation up to the right, where it is quite a factor of 10 at least. And what happened since 5 years ago? This is more, last time nobody did the two different calculations. So that's an improvement. But the use of the standards are still better, and some programs have developed routines for the thermal bridges, and it's not really proving that the programs have their own interpretation of the thermal bridges and the area, so it can be different. Visualization is improved in some cases, so things happen. And thank you for listening to this, which will conclude my presentation.